2 men, 2 philosophies, 2 choices, 1 decision. You decide.
My goal tonight is to teach you something about science in general and evolution in particular. I'm going to assume that you're intelligent, but to some degree uninformed about these fields. There's some common misconceptions about the theory of evolution, but basically it just says that all living organisms on Earth today are descended from a few species that lived many millions of years ago. One big misconception about evolution is that it's somehow anti-God. But in fact, nothing in evolution argues against the existence of God. I believe the process of evolution is part of God's creation. Another big misconception is that evolution is, quote, just a theory, unquote. But in fact, there's extensive evidence for it, and that's what I'm going to tell you tonight. When we want to understand or explain something, we use the scientific method, which is really just careful application of common sense. First, we form a hypothesis, and then we test it. We do this by deriving deductions or predictions that follow logically from the hypothesis, and then testing those predictions by observations and experiments. A good hypothesis has to be, in principle, falsifiable. That means there must be tough tests which, if the hypothesis were really wrong, would disprove it. Then if the hypothesis passes all those tough tests, we conclude that it must be true. So let's take a look at the hypothesis of Dr. Hovind concerning the history of life on Earth, creationism. This says that the Earth and all living species were created in 1 week, about 4000 BC. Species don't change, and the Earth's features were shaped pretty much by a worldwide flood about 2400 BC. Now, 200 years ago, pretty much everybody accepted this. Even Charles Darwin was a creationist as a young man. But then people began to test it as a scientific hypothesis. And it failed all the tests. It became clear that the Earth is much older than 6,000 years. It's millions of years old, that living species can change over long periods of time, and that there just isn't any evidence for the supposed worldwide flood. So, Charles Darwin came up with the hypothesis of evolution by natural selection. This says the Earth is very old. Living things can change over generations, many generations. Living species can diversify into 2 or more separate species, and all species on Earth are descended from a few ancestral forms that lived in the distant past. The idea of evolution had been around before Darwin, but he made 2 big contributions. First, he proposed a plausible mechanism for how living things could change, natural selection. This says there are inherited variations among individuals. We now know that this is due to chance mutations, chance genetic mutations, and second, variations which favor survival and reproduction will be selected because they have a better chance to make it into the next generation. Similarly, unfavorable traits will be discarded. Darwin's second big contribution was that he followed the scientific method very explicitly, deducing predictions from his hypothesis and then testing them. And I'm going to go through Darwin's deductions as well as some more modern ones. Darwin's deductions number 1 through 4 were tests of natural selection. There isn't time to discuss them now, but it has been well established by field studies and mathematical models that natural selection works. In fact, it's got great practical relevance to understanding things like antibiotic-resistant germs and pesticide-resistant insects. Even creationists acknowledge, as they must because of these examples, that natural selection works, but they claim that it can only lead to small genetic changes. In fact, given enough time, major changes are not only possible but inevitable. For example, in human cells, about 50 to 100 mutations creep in per human generation. That's not much, but if it goes on for 1 million generations, several % of the human DNA will have changed. So small changes can accumulate, and given enough time, the character of a species can change significantly. Now, this implies, from this it follows that if evolution is true, the Earth must be a lot older than 6,000 years, and it is. Astronomy, geology, and biology together provide us with a coherent and consistent view that the Earth is about 4.5 billion years old. Now, we can actually date rocks fairly precisely using radioactive atoms, and I want to take a minute to explain this. Radioactive decay is where one kind of atomic nucleus decays into another, like rubidium-87 decaying into strontium-87. The decay occurs at a constant rate, which is expressed as the half-life, the time it takes for half the remaining rubidium nuclei to turn into strontium. And we know the half-life of rubidium-87. That can be determined. So basically, if we measure the ratio of rubidium-87 to strontium-87, we can figure out how old the rock is. In practice, rubidium-87, strontium-87, and another strontium isotope are measured in many different minerals within the same rock. And the results are plotted. If the rock is just formed, those will form a straight line. But if the rock has been around for a while, and if the composition hasn't changed since it was formed, the points will fall on a straight line called an isochron, and the slope of that line tells the age. Here's an example of a rock from Michigan that was dated this way at 3.5 billion years using 30 different minerals within the same rock. Results can also be checked by using other isotopes. There's quite a few different isotope systems that can be used. The take-home lesson is that radioisotopic dating is really far more sophisticated and reliable than creationists would have you believe. Okay, so far we have a mechanism for gradual genetic change and enough time to account for lots of such changes. But has evolution really occurred? Well, Darwin's deduction number 6 is that if evolution has occurred, then species that lived in the remote past should be different from those that live today. And we can test this because we have fossils. It turns out that the vast majority of fossil species are different than those alive today, and that doesn't just include dinosaurs. Now, we can actually make a more sophisticated deduction. Deduction number 7. If evolution is true, that predicts that the percentage of fossil species that are the same as contemporary species should be lower in the older rocks than in the more recent ones. Note that the older rocks are those that are lower down because they were laid down first, and the newer ones were laid down on top of them. And this has been tested many times and confirmed always. Here is some data from Lyell in 1854, which was before Darwin published his work. In the more recent Pliocene rocks, you can see here, 96% of the fossil species were the same as species that are still alive. And in the older Eocene rocks down here, only 3% were the same. Okay. Deduction number 8. If evolution is true, it must be possible to demonstrate the slow change of one species into another.